couple days ago?
Quiz?
Yeah, I got a quiz grade back. I don't remember which one it was.
Oh. March 49th. How do they say? What is the saying? How about to know? Let's see here. No, the what's that? Quiz 6 has been graded and returned to you guys. What has not happened is that I have not put the grades into Canvas. And so what this means is that somewhere in my office, there's a sheet of paper with numbers on it. Those numbers are your grades. And if I find it, I'll put those numbers in. But if I don't find it, as I'm cleaning my office sometime soon, then, no, it'll be sooner than that. Then you all will have a very good score. So, yes, sir.
Okay, I can just tell you, I remember what I got. I got a 342.
You got a 342. Yeah.
So it's okay. You don't have to find it.
Well, that's very, very kind of you. Although, fun story, like we did have WebAssign, like randomly putting grades of 900 into some like homeworks in a previous semester, like not like 900, like actual course points. It was like, what? And then I don't know, like their software did something screwy, and then it was a thing.
Like 1,200 out of 1,000. It's like half a
Yeah. The people in charge of things said things to the people at WebAssign, and the people at WebAssign were like, okay, we'll fix it, you know. And what?
So why? Because students were all for it.
Well, yeah. Oh, let me begin with a word of prayer before I forget. Dear Heavenly Father, we thank you for today. I thank you for these students. Just ask that you just bless our work today. Help us to glorify you what we do, and just to wrap up our thinking about graphing rational functions. Lord, in your name I pray, Lord Jesus. Amen. So, do you guys have any questions about the mission before I get into more examples of graphing rational functions? I mean, I certainly need to show you more examples, but I do have a couple minutes today to talk about anything that was confusing to you and the homework. Now, the homework is due when? Tuesday. Yeah, Tuesday started class, which I guess is also known as April 4th? Yeah, that's not. I'm double checking the date there to make sure I'm not being trapped here. Yes?
I have a question about questions like problem 42. There's like 2 ones. It's like the CXA, YB. I know we did those a while ago.
Yeah. So what about the problem 42?
I was having a hard time getting getting answers that I felt like were correct.
Let's see here. So, I mean, I can talk about that for. I mean, there could be fractions. The answers don't have to be pretty. Like here, I'll do part C for you guys. I have 1 over x times x squared, square root of y, all right, times y to the 3 halves over x, and you're supposed to find a constant and an a and a b such that this equality is true, right? So what should I do here? So what I do is I collect things that are the same, you know. So I've got x squared upstairs, right? And I've got x times x downstairs. And I've got y to the 3 halves. And this square root of y, what's that? That's y to the 1 half, right? So in this case, the x squareds cancel, right? And you're just left with y to the what? What's 3 halves plus 1 half? 4 halves, otherwise known as 2. So then you have to use your imagination here. This is 1 times x to the 0 times y to the 2. So I read from this c equals to 1, a equals to 0, b equals to 2. And that's it. So that's like 42 part C. And I could see why that might have been confusing to you because, you know, you feel better if you found like A and B were 3/2 and minus 7/3 or something, right? And C was a number, but it could be 1, you know? And A and B could be 0. That just means that there is no explicit power. Yeah. Other questions? Yep.
Could you do something similar to 72?
72. Oh, yes, very good question. So we're supposed to consider so I'll write up here what problem 72 is, and then I'm going to change it just a little bit, okay? What's that? What if I didn't? Well, then I would deprive you of the joy of the learning. You're okay with that? Minus 2. It said sketch the graph, label any x-intercepts, vertical asymptotes, horizontal asymptotes, and any holes in the graph. All right, so those are the terms and conditions of the problem. So there's two ways to go with this problem. The one way, you could just graph everything here except for the minus 2, right? One way you could graph this would be to, like, and you know, I'm not sure which is easier, okay? So like, my first idea is to graph y equals to 12 over x plus 4 minus 3 over x minus 3, right? And then step number 2 is to shift down 2 units to get y equals f of x, right? Does that make sense? Do you see why that's a reasonable approach?
You're the y.
Yeah, yeah. Now, the other approach, now the downside to this approach is it might not be obvious where the x-intercepts are, right? So that's one approach. The other approach is to make a common denominator, right? Like this. Let's see here. So I get what? 12 times x minus 3 times x plus 4 divided by x plus 4 times x minus 3. But I've also got this 2 term here, so I have to do minus 2 times x plus 4 times x minus 3. So I just made a big old common denominator of x plus 4 times x minus 3. And how's that work out? All right, 12x minus 36 minus 3x minus 12 minus 2. I'm going to multiply that out. X squared plus x minus 12, all divided by, still, x plus 4 times x minus 3. So if this doesn't work out pretty, then I'm just going to tell you guys use the purple approach, okay? Let's see what happens. So what do I got? Minus 2x squared, right? How many x's do I have? Let's count them. 12, right? Minus 3 is 9. And then minus 2, 7. So plus 7x. How many constants? Well, minus 36 minus 12 is minus 48. And then I got plus 24, so a net of minus 24. And still x plus 4 times x minus 3. Now that's a quadratic, so we can factor it, all right? I think factoring the minus 2 out front, oh, but the 7, ugh. I can't think with minuses. I'm going to pull that minus out front, okay? If that's okay with you guys. So I have minus parentheses 2x squared minus 7x plus 21. If it does factor nicely, that'll help me. Oh, yeah, sorry. There we go.
With the original, the negative 24 would be positive. Is it negative?
It would, but I had a minus 36 minus a 12, which gave me a minus 48, and that was what it was up against. So minus 48 plus 24 gives me the minus 24. But, and does that factor? I mean, I don't know, maybe. I mean, I do 2x, I do x. At this point, the question becomes, is this a problem I made up, or is this a problem I copied down from a book somewhere, right? If it's a problem I made up, odds of this factoring are pretty low. If it's a problem I copied from a book, it might work, who knows? So 24 is 3 times 8. It's 2 times 12. It's 1 times 24. It's a lot of things, right? I want a minus 7 in the middle. So I need, yeah, they need to both be negative. Well, no, yeah, they have to both be negative because we got a plus 24, right?
Could it be prime?
What's that?
I said would be prime and stuff like that before.
I mean, I don't think it's going to work out. I mean, I don't think it's pretty. It's just to confirm my suspicions, I'll complete the square. 2x squared minus 7x plus 24. If we complete the square on this, it's 2 times x squared minus 7 halves x plus 12, which is 2 times x minus 7 quarters quantity squared minus 49 over 16 plus 12, which is nothing nice, I don't think. I really hope my calculator's in here today. Woohoo! I don't know, what's 12 minus 49 over 16? It is 143 over 16. Well, what do you know? So 2x minus 7 over 4 squared plus, ooh, really? Oh, really? Interesting. Is that right? Yowzers. 143 over 6, what does that mean? For one thing, it means I'm working too hard, right? Because I could have just gone here and I could have been like, well, b squared minus 4ac for the top is what? It's 49 minus 4 times minus 2 times minus 24. And I could have observed that that's less than 0, which would have told me what about this quadratic? The quadratic in the numerator actually is what? It's prime. It can't be factored. So I'm kind of ambivalent. On the one hand, so I still could go either way. I could go the purple way or the black way, because like the black way, I've learned now that there's no x-intercept. I can deal with that. No x-intercept is fine, you know? That means the only place that this graph can cross the x-axis is at vertical asymptotes, apparently. So I'll just go back up to this step right here. And I mean, this is not wrong, but it doesn't matter. Can I erase it? Okay. So how do we graph this then? Well, I mean, first of all, what do you guys think what do you think would be easier, to graph the one in the purple way and shift, or do this algebra? Probably the purple way, right? But since I did the algebra, let's just stick with it, right? So what are my critical numbers? Critical numbers, remember, what I mean by that are numbers either where the numerator is 0 or where the denominator is 0. But we just figured out that the numerator is prime, which means, what's that?
So -4 and 3?
Yeah, just -4 and 3, because there are no critical numbers from the numerator, corresponding to the fact that this will not have an x-intercept. Okay? And so my number line, it's kind of boring, -4. Actually, what am I saying? It's not boring. It's actually very, very exciting. So what happens when you plug in 0? Listen, you got choices. You can plug 0 into any number of formulas here, right? You could plug 0 into our last formula. You could plug 0 up there if you wanted. What'd you get? If,
24.
yeah, -24 over -12, right? So f of 0 is actually 2. And you probably could see that from up here as well. If I plug in 0, I get what? 12 over 4 is 3. Plus 1 is 4. Minus 2, 2. F of 0 is 2. So however you slice it, it's positive in here, right? Then the thing is, the numerator, it never changes. It's like always negative, I think. Right? The numerator polynomial is always negative. It never becomes positive. And on the other hand, these guys flip signs, right? So this x minus 3 factor flips as you go from here to here, and the x plus 4 flips over here. So this is your sign chart. Once you know the sign chart, you know the critical numbers, you can graph the function. See, because the graph of the function, it's got 0 about here, right? And I won't do this quite to scale. What's the other thing I guess I have to, so the vertical asymptote's fine, but what's the horizontal asymptote for this function? I'm sorry, I seem to be working your homework problem. What's that? The horizontal asymptote you said is 2? I almost agree with that. Well, that's the y-intercept. Y-intercept is 2. That's fair enough. Like the y-intercept is 2. True. What is the horizontal asymptote? Is the long-term behavior of the function. All right. So like if this is, say this is 2, for the sake of discussion, that's a point on the graph, right? And it's positive, right? So that means that the graph between these asymptotes has to do something like this. It has to bow up like that. It has to go to infinity at the vertical asymptotes. The vertical asymptotes, these green lines, they're places where the function's not defined. I should also draw a horizontal asymptote for this because it's, okay, so sometimes the horizontal asymptote is the x-axis. Sometimes it's not. Sometimes it's like a horizontal line. Look, you can see the horizontal asymptote for this problem by looking at the original formula. Think about what happens if you plug in a stupidly large number, either positive or negative, into this formula. What happens? You got 12 over something ginormous. That's essentially 0. You've got 3 over something ginormous. Again, essentially 0. So for x really, really big in the either positive or negative direction, the only thing that really matters here is that. So if you try plugging in 1,000 and minus 1,000 into this formula, you should get something really close to minus 2. And so what I'm saying is that there is a horizontal asymptote of minus 2 for this function. So this is the horizontal asymptote for the graph. And so what the graph is going to look like is something like this. So it blows down to minus infinity there, and then over here like this. And there you go, that's y equals f of x.
What was our y intercept for the ground level?
This right here was 2. We figured that out by plugging in f of 0 was 2. So that's why I know that. But there are no x-intercepts. Yeah. So if you graph the purple, yeah, what we would have got is the same shape, but like shifted up 2. So I don't think I need to also do that with you guys. Is that okay me not do the purple way? Let me not do the purple way.
And so how do we check if there's holes in it?
So there will be holes in the graph if you have a matching factor above and below. So like, we can do an example of that. Example 3, suppose I had f of x equal to, let's say, x plus 1 squared times x minus 3 divided by, let's see here, x plus 2 cubed times x plus 1. There. I made this one kind of easy in the sense that it's already factored, okay? What are my critical numbers? Let's graph this. So our graphing instructions is tell me any vertical asymptotes, tell me any horizontal asymptotes, tell me any x-intercepts, and label any holes in the graph, okay? That was like the last time I taught this course, I had a question where I'm like, here's a function, and I have 3 blanks. Find any, tell me where the x-intercept is, tell me where the vertical asymptote is, tell me where the hole in the graph is. That was a problem on the test last semester, right? So that made sense for that problem because there was just one of each for the function. I can show you that problem if I can. Oh, I don't know if I have it on that laptop. Sorry. But anyway, so this one here, what are my critical numbers? -1, 3, -2, right? And so when you're going to possibly get a hole in the graph, and it's not guaranteed, mind you. Like the hole in the graph could also degenerate into a vertical asymptote if you have more factors in the denominator. If you have more factors in the numerator, well, if they're equal, it could be a hole in the graph which is somewhere else, like we had last time. It was at 1. If there's more factors in the numerator, it's going to put the hole on the x-axis. That's going to happen for this one. See, so you see there's a doubling up here and here. So if I reduce this function, the reduced function is this, right? X plus 1 times x minus 3 divided by x plus 2 cubed. So this is what I would call the reduced function. So the reduced function, what it does is it basically fills in any holes in the graph, like if possible. The reduced function will just have a vertical asymptote if it's not really a hole in the graph. But the reduced function is very simple. You just cancel everything you can. Okay, that's it. And so anyway, let's make our sign chart. We've got what? -2 comes first, -1, 3 is over here. Plug in some values, see what happens. What do you get? If I put 0 in, I usually do that because it's easy. 0 gives me 1 squared times -3 over 2 cubed times 1. So if you look at the pattern, you've got plus, minus, plus, plus, so we've got a negative, right? So we've got negative between where we change from positive to negative at 0. Minus 3, excuse me, at 3, that's from this x minus 3 factor, right? There's just one of them, so we change signs to plus. Minus 1, how many factors corresponding to minus 1 do we have?
3.
We have 3, right? Exactly. 2 upstairs, 1 downstairs, but that's a net total of 3. That's an odd number. That means we're going to flip signs at minus 1. And if you doubt me, well, you could try plugging in like minus 1.5 and see what you get, okay? And then what happens at minus 2?
Flips this well.
It flips, yeah, it's odd again. It flips as well. All right, so let's graph this thing. Now, I made it easy on us, in a sense. What's the horizontal asymptote for this problem? Note, the horizontal asymptote is y equals to 0, since f of x is proper rational function. What I mean by that is upstairs you have degree 3, downstairs you have degree 4, right? So it's a cubic over a quartic, which means eventually the denominator wins and the graph gets closer and closer and closer to the x-axis, which is to say that the x-axis is the horizontal asymptote, right? So not like that minus 2 in the previous one we looked at, yeah? Okay, so that's nice. Where are my vertical asymptotes? You gotta be able to tell the difference between the vertical asymptotes and the hole in the graph, right? Let's see here. So we got Man, this marker's kind of sketchy. We got 1 at minus 2, and then is minus 1 a vertical asymptote? It's not, right? So that's actually a hole. That's right. So at minus 1, there's a hole in the graph. And let's see here. I guess I can graph it now. So it looks something like this. And then crosses right there. And what happens at minus 1? Oh, yeah, it's a crossing. I'm a dummy. And then what? What happens at, I guess my real question is, what happens at 3? Yeah, 3 is an x-intercept, right? 3 is an x. How do I know 3 is an x-intercept? Because why?
Because it becomes positive and also because it's in the numerator.
Oh, because it becomes positive and also because the x minus 3 is in the numerator, right? So yeah, those are both contributing to that conclusion. So, and then what has to happen? It has to do what? It has to bend back down, because its fate ultimately is this horizontal asymptote at y equal to 0.
Does it ever cross the x-axis again?
No. If it did, the algebra would have to show it.
Right. I was going to say, because it didn't get negative, but it just curves down.
Yeah.
Which is
It just kind of, you know, you can check your answers. With, how dare you, being photo math. This is,
oh, Wolfram alpha?
yeah, I mean,
Wolfram alpha is my best friend.
with photo math, yeah, fine, probably, but I prefer Desmos because it's like pretty and stuff, and not just manifestly something for cheating. Let's see here. Y equals to what are we doing? X plus 1 squared. You guys gotta help me out. Times what?
X minus 3 over x plus 2 cubed times x plus 1.
So it was x plus 1 squared times x minus 3 divided by x plus 2 cubed times x plus 1?
Yeah.
Okay. Huh. Now, I will say this. It may or may not be the case that Desmos actually does the hole in the graph. I wonder, I mean, photomath might even do better there. Who knows?
What about Wolfram Alpha?
Wolfram Alpha is a little bit finicky with graphing, but it might work. We could try it. I've done this much work. I mean, I've done this much typing. Chat GPT. Yeah, I don't know about that. So here's the graph to scale. I think you can see that this is what we have, right? But it's really hard to, you see this, like it's mine is much more dramatic than the truth, right? The truth is, it kind of just, and that might be, oh man, what is that? I wonder what that is. I think that right there is that might be the hole in the, no, the hole in the graph should be at -1, right? So it doesn't respect the hole in the graph, right? Okay. So, oh well. But if you look over here, it does go up for a bit, but if you go far enough out, it starts to bend back down. It may be a while. A while. Like a really long time.
It's starting to get closer.
Let's see here. Let me zoom out. So as you can see, it's getting closer and closer to the x-axis, right? Okay.
Yeah.
I mean, if you zoom out. But anyway. So listen, this is important in terms of what am I expecting from you for an answer. I'm actually more interested in an answer that illustrates that you understand the principles of graphing, like this. Like this is wrong, technically speaking, for this function in terms of like it's not actually the shape, right? But I draw it this way so you can see what the ideas are, right? Fair enough. To make it exactly to scale it's much harder to see precisely what's going on because like some of the features in the graph are so small compared to other features which are so large. So I just choose to draw a slightly heuristic picture where you can see all the ideas. Now, if I had a really good example, it would be concocted so that all of the features actually are big in the graph itself, right? So there wouldn't be any need for a heuristic graph. You could just draw an accurate graph, which would also be a pedagogically correct one. Yeah?
Can you explain to me one more time how we did it before you shows back to the x-axis rather than just going up?
Oh, it's really simple. It's just that the numerator has degree 3, the denominator has degree 4, which means eventually denominator wins. So that means that the horizontal asymptote is the x-axis, which is to say that the graph gets arbitrarily close to the x-axis eventually. Think about it this way. If you plug a billion into this formula, in the top you've got like a billion cubed. On the bottom you have a billion to the 4th, which is essentially like 1 over a billion. And it just gets worse from there. So, I mean, I don't need to use a billion. I could have used 1,000, right? I mean, so. In contrast, if I'd plugged 1,000 into my example I did from your homework, we would have got -2. Well, we might have got -2.001 or something, you know, but.
The higher than we plug in, closer to the smallest fraction it becomes.
This is true.
It's never 0.
This is true. If you want to figure out what the horizontal asymptote is for a graph and you're shaky on your algebra, you can easily plug in a very large number in the positive and negative sense to see what the horizontal asymptote should be numerically. And even if you can't do the algebra, you can say, I know the horizontal asymptote for this function is such and so forth because I plugged this number in. I'll respect that. I mean, that's a legit way of figuring out where horizontal asymptotes are. But it's not the best way, but it's a way. So I don't know what's going to happen to us if we try this in Wolfram. Let's see if I can cut and paste it. Do, 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 do. It's it has one root at 3, right? Yeah. If you want to know where it's biggest, it's at 4 plus the square root of 21. That's where it turns around and goes back towards the x-axis. That's past 3. So it actually happened around 8-ish. And see, so it's done everything except for graph. I guess if I just put the word graph. Oh, yeah, my bad. I just didn't even see it. I'm a dummy. But I don't think it, as you can see, it also doesn't really show the hole in the graph, right? I mean, I guess you could say hole in graph. See if it does it. I don't know. I mean, Wolfram Alpha really is a form of chat. It is like Chat GPT. It is an artificial intelligence aided math input. Like it doesn't require a certain format. It takes your format and it feeds it through like an artificial intelligence to reformat your question to something that makes sense to Mathematica to answer the question. So it is very much the same thing. But it won't write English papers for you, I don't think, but it'll do more interesting things. Oh, I'm sorry. Wait a minute, did I say that? What am I saying? Well, I think it basically balked at my, it's like, yeah, whatever, I'm going to ignore you. Fine. I was created by Stephen Wolfram. Yeah. Oh, sorry. I think we have now entered the joke portion of the class. Let's see here, since I got this out.
We lost the.
Well, I can't, if you see it, you know the answers. I tried that in physics the other day. I'm wise to you guys. I warn you, these are written by an 8 or 9-year-old, so you may not get these. They may be too sophisticated for you. Where do houses like to shop? That is a good answer. But yes, the answer is not Home Depot. The answer is Walmart. Where does Han Solo shop? This one's actually better. What's that? The answer is Harrison Teeter. So stupid. What kind of car is very small?
A small one.
The answer is a minivan. Ah. What is the bummiest place to get electronics? Ooh, this is very politically incorrect, I think. Very good, Radio Shack, yes.
Why is that politically incorrect?
Because it's a shack, you know, a bum lives in a shack. What kind of music do Stones like? Rock and roll, very good. Yes, I think that's a canonical dad joke right there.
You wrote these, didn't you, Mr. Good?
I did not write these.
You're really funny. You wrote these and you were like, guys. If you don't like them, they were written by an 8-year-old.
No. Oh man, you guys are killing me. All right, just a second here. Let's see here. Yes, our exam is a week from today.
But we don't have any more quizzes, right? Or do we have a quiz on Tuesday?
We have, yeah, there's a quiz and a mission due. What he said.
So the quiz is on graphing?
Yeah, the quiz is on graphing rational functions. Oh, you guys tricked me into working the last problem in the homework. That's the hard one. Hey. Hey.
It was a trick. You put
You did tell us you weren't going to do it.
Yeah, I was gonna change it, but then
It was funny because I even said, what if you didn't change it? And you're like, oh, then I would deprive you of the joy of learning.
yeah,
But I wasn't going to correct you.
that's just because I'm a monster. I like to deprive you of joy. So let's see here.
Yeah, we experienced the joy of it together.
So I have, like in terms of content, I think I've showed you everything. So really, we just have time for more examples now. I don't think I've missed anything per se, but we could look at a reverse problem.
Oh, yeah. Algebra.
So how about this, guys? So let me do one more easy example, like easier example. There's some like these in the homework. You could have something like this: f of x equal to x plus 6 over x squared minus 36. And again, find any x-intercepts, any vertical asymptotes, any holes in the graph. Graph it. Graph the horizontal asymptote, whatever it is. So what do we do here? Yep. And what does this mean? So this is the reduced function, right? And so what's the story here then? My critical numbers are minus 6 and 6, right? And what else we got here? So try plugging in 0. What do you get? 6 over minus 36. So is it positive or negative? It's negative, right? And then let's see here. At 6, we've got two things, so it stays negative. And at minus 6, we only have one, so it flips. Right? Where is the hole in the graph here? The other one we did today, it was easier because the hole in the graph was on the x-axis, so we saw that. I erased it, unfortunately. Oh, no, I didn't. See this? What happens when you take f reduced and you plug in where the hole is? The hole was where? A 3, right? No, 1. Minus 1, my bad. Minus 1. What happens when you plug minus 1 into this? Right. Now, do I really need to write all this? Once I see that that term is 0, it's what? 0, right? So hole at minus 1, 0. I just put that on the graph. I didn't explain to you how I knew that. The reason I knew that that graph, that the hole was there, is because when I plug minus 1 into the reduced function, that's what I get. All right? Right. So over here, to find the hole, we want minus 6 comma the reduced function at minus 6. What is that? It's not 0 because it's minus a minus 6, which is minus 1/12. See, so it's right. Yeah, if you plug it in the other place, you get 0 over 0, which is, why it's undefined. But, so, all right, great. My y-axis is like here. My x-axis, I'll put right to here. I got a vertical asymptote at where? Oh, I just remembered. I can find last semester's test by going into Canvas. I'll load it up here for you guys in a minute. We've got a vertical asymptote at where? See, at 6, right? That's still there. So at 6, there's a vertical asymptote. Is that right? Sorry, it feels wrong. No, it's fine. It's fine. It's fine. It's fine. My bad. It's fine. What did we get for f of 0? What was the value? Do you guys remember? It's like 6 over minus 36, right? So it's like minus 1/6. It's pretty tiny. So let's just for the sake of scale, let's put it here. All right, so that's minus 1/6. And this does what? We have a x-intercept at wait a minute, do we have an x-intercept? We do not. Wait a minute.
Yeah, we did a negative 6.
Oh, I'm an idiot. Is this sign chart right? Yes and no is a good answer. So where is the yes? The yes is in the middle where we checked it, right? But the no is over here because how many x plus 6 factors are there?
2.
2. So this is mine. I was starting to have a really hard time figuring out how to graph this, and the reason for that is the sign chart's wrong.
Okay, so then wouldn't that be, I have a whole loss because there's only one,
Right, because there's only one x minus 6. There we go. Now hopefully things will start to make sense. All right, so there is no x-intercept over here. All right. Who was that? You can wait till after class. Come on. This is important. Okay. No, it's... Okay, anyway, so students sometimes ask me how math is applied to the real world. And I always ask them, are you in the real world? Because you're going to be taking a test next week. Seems like an application to me. Unless you deny your own existence, you know.
High school teacher used to just say, well, it's used in the real world to the extent that you need a high school diploma to graduate.
So your high school teacher gives the same answer I do then. That's very good. Okay, so minus 6, what happened there? Oh, it had a hole, right? And the hole was where? It was halfway, minus 1/12 is halfway between the x-axis and the y-intercept, right? So I should have it about like halfway up if I'm trying to be vaguely careful. So, and it's a hole, so I make it a hole. That hole is at minus 6 comma minus 1/12, right? Minus 1/12 is halfway closer to the x-axis than minus 1/6, right? And then so the horizontal asymptote is 0, so it kind of does something like this. And then gets through here, goes way down there, like that. And then on the other side, blows up to infinity on the right side, and then it comes back down like this. Right? And there is no x-intercept. Oh, hey, what's the range of this function?
negative infinity to 0. Oh, negative infinity to negative 1/12 to 0, not including to 0 to.
I think that's what you said?
Yeah.
Okay. So right, in other words, take the real numbers and exclude what? 0 and where the hole is, right? What's the domain of the function?
Negative infinity to 6, union 6 possibly.
Right, so what, I mean, so let me put it in different words. Like what you're saying is take the real numbers and delete which numbers? Negative 6 and,
Oh, or 6.
yeah, negative, yeah, negative 6 and 6. So, listen, to figure out the domain of a rational function, it's a pretty simple question. All you have to do is look at the denominator. Wherever the denominator is 0, you got to throw those out. So if we have x squared minus 36, that's 0 for plus or minus 6. So the domain of this function is everything except for plus or minus 6, right? give me a second here. I have to walk down memory lane and find my way back to last semester. One of my college algebra courses, and I will find their test. We'll look at their test. Why don't we do that? That would probably be a good thing to do, wouldn't it? Maybe? What do you think? Give you a sense of what the next test looks like, give or take. It's not quite right, though, because I've changed the syllabus, but I will talk to you about which problems are, you know, most relevant as soon as I can find it. All right, let's see here. So like last semester, I more directly followed the book, so it's a little different, you know? This semester, I just decided that I'm going to follow my heart, like it says in the Bible.
That's true.
It actually doesn't say that. It says that the heart is desperately wicked above all things, and who can know it? This is Jeremiah 17:9. It's a good verse to think about. Let's see here. Well, all right. I think yeah. Okay, this one's it. Now, some of these things kind of already happened for you on test 1, right? Like, and so like, here I had a, you know, pick which one's which question, and a lot of people got this right. And you just guess. And not everybody, though. Let's see here. This is the one I was talking about. So here we have x squared minus 2x minus 3. All right? And the question is, you know, where's the hole in the graph, right? Where's the vertical asymptote? And you already got it. Cool. Well, yes. But thank you. So to solve this problem, oh, come on. What? How dare you? What? Nope. Man.
Maybe you should spike it on the ground.
You guys could like work for Whistling Diesel. Anyway, I said you could be like Whistling Diesel's, like the guy that stands by and tells him to do things. You know? You didn't know what I'm talking about?
Yeah. I don't know. I know.
Oh, okay. There's a guy on YouTube who makes his living like destroying trucks.
Oh, yeah. He tied over a Ferrari in the woods.
Yeah. He has underlings who are like, you know, tell him things like again or go over that or, you know, things like that. You could be that guy. Yeah. Like this suggestion that I should spike my laser pointer in the middle of class. It's in that category.
I don't know. You're like banging it on stuff. Maybe it'll help.
Well, I mean, Cody does bring that to the table. I mean, that's true. But anyway, let's see here. I mean, I try to do my part. Oh well, I think it may be time to buy a new laser pointer or replace the batteries, whichever comes first. But anyway, so the larger point here. Sorry, guys. Yes. Thank you. Yes. Okay, so the first thing you want to do is to factor. Once you factor it, then you can see where's the hole in the graph versus where's the hole in the graph comes from Same thing above and below. So there's a hole at 3. There's a x-intercept at -1, because that makes the numerator 0. There's a vertical asymptote at -3, because that makes the denominator 0. So that's how I answer this. The x-intercept is at -1, 0. The vertical asymptote is at -3. And the hole in the graph, that's the one that actually requires a little bit of calculation. See, because I have to plug 3 into the reduced function, and when I do that, I get 2/3. So the hole is actually at 3, 2/3. All right? So there's an example. Let's see what's next here.
Can you do that for just a second?
Yeah, sure.
Got it.
Mm-hmm. If you ask me nicely, I might even post this in your Canvas if you guys like. Would you like me to post this PDF in your Canvas? I mean, I can do that. It's not a big deal. If I forget to, poke me, please. By email. Here is, function operation question with a graph. So, f g of 2 is f of 2 times g of 2, right? How do you figure out what f of 2 and g of 2 are? Well, I have to look at the, I made g equal to give by the formula. I gave f by the graph. So to figure out g of 2, I plug 2 in here, I get 7. To figure out f of 2, I look here, f of 2 is 2. So 2 times 7 is 14. F of g of -2, well, g of -2 is apparently -1. And then f of -1 is 0, so that's why we had 0 here. G of f of 0, well, f of 0 is 1. That gives us g of 1. Plug in 1 into here, we get 2 times 1 plus 3, which is 5. So that's like how that goes. This one here is a graphing problem, kind of like what we've been doing today, right? More or less. And this one, no hole in the graph, right? It's just got your x-intercept and your vertical asymptotes. The vertical asymptotes are at -6 and 4, see? And there's an x-intercept at 2, right? And as you can see, I drew the sign chart up here just because that helps me organize my graphing, yeah? And on your test, you can expect this kind of grid to graph on if I ask this question, all right? So like I would try hard not to do what I did on the quiz to you guys last time, which was the just freehand white paper graphing. That was, well, this is the part of the semester where my schedule breaks, so I ran out of time. But I will make time to make your test. That is a guarantee. Anyway, so anyway, any questions about this? Yeah. Let's look at another one here. Here I give you f of x is x to the 4th plus x cubed minus 13x squared minus x plus 12. I said evaluate f of 1 and f of -1 and factor f of x completely. So if you evaluate these, you get 0 for both, which tells me that x plus 1 and x minus 1 are factors. So I can multiply those. That means x squared minus 1 is a factor. So I can divide x squared minus 1 into this quartic, and then I factored it. See, because that gets me to, well, sorry, I got to scroll down a bit. So that gets me this, right? But then this factors to x plus 4 times x minus 3. So there you go. So there's, the factor theorem paired with long division, paired with the graphing, the factoring you already know. This is, something I usually test on in this part of the course. I'm kind of lazy, so I think you've seen this problem in your homework somewhere, maybe. There you go. Recycling. Graph x to the 4th, woo, plus, whoa, x to the 4th plus 4x cubed plus 5x squared minus that.